right? Okay. So for the second part, we will talk about this image processing, and now I'm going to tell you some of the theory part. Then I will pass to our colleague in Jupyter Robot to show you the actual example. Okay, but before that, let's just start with the introduction. Okay, so I'll skip this. So basically now we go to the second part that we are going to discuss about this image processing. Okay, so for image processing, okay, the digital image processing actually is a process to process digital images through an algorithm. Okay, an algorithm can be a math algorithm and so on, because you know digital images actually are array of figures, okay, data or like value. RGB basically is 0 to 255 for R, for G, for B. So you got like 3 value, and then you have the whole picture for all the pixels. So you have a big array of numbers. So these numbers, it actually give you certain pattern, and also by applying mathematical algorithm to this array, then you can actually do some analysis and also do some processing to obtain certain objective. And this whole process is what we call the image processing. Okay, and there are many application for this image processing, like classification. You can classify different things. Features extraction. You can extract, for example, like the way how we actually recognize certain thing, or certain track certain object in a photo is like using the features extraction. So we extract certain features and then we track the features and so on. Then we have other things, for example, like multi-scale signal analysis and pattern recognition. Yes, pattern recognition we use a lot. Okay, use a lot to find certain pattern. For example, like how you find the outline and so on. So those are pattern recognition. Okay, so there are many techniques, projection and so on. Okay, so you can go to like Wikipedia page and see like what are those, like a lot. Okay. Okay, but for this class, we are not going to talk a lot in the theory, like how is the algorithm, how you want to do it, but we will straight away show you like how to do some example or some application. Okay, then you will have some idea like how to use this thing to develop your application. Okay, so there are a few things like I will just introduce you this. So later on, I'll pass to engineer in Jupyter Robot to show you the example. So the first example that we show you is the OpenCV cam shift filter. So this is one of the example in the ROS OpenCV application library that I just introduced just now. So the procedure is like you need to bring up your sensor. So you need to get the sensor ready. Then you need to know your image topic. Okay, because different sensor, when you run the driver, it will give you like, it will actually like feed the data into a particular data topic. So for the USB camera, the topic is this USB_cam image raw. And for Astria, the RGB the RGB data is fed into this camera RGB image raw topic. Okay, and you can find more topic once you launch the sensor. Okay, so in order to launch this cam shift node, this is how you need to do for USB camera. So you launch it like the cam shift, then you need to specify where is your image topic, or what is your image topic. So you specify over here. So this is the difference between these two. Okay, so then we have the face detection, which is the same procedure. You bring up, then you use the image topic to launch, for example, the face detection using the cascaded classifier, or face recognition, or people detection, and so on. Okay, so these are a few examples that I would like to introduce our colleague in Jupyter Robot to show you the example. Okay, so may I introduce David?
Yes, I'm here.
Okay, so I'll pass the screen to you, and please show us the example.
Okay. I will share my screen.
Okay.
Can you see the screen?
Not yet.
How about now?
I'm still waiting. Maybe my side is a bit lag.
Yes, I can see.
So you can see the virtual box, virtual machine, software, which
Yes.
is Jupyter Sim. Is that here?
Yes.
Okay.
Yes.
I will start the demo. First time we'll show you how to connect your USB camera to the Jupyter Sim virtual box virtual machine, which means if you use the virtual box software, you need to mount your device to the to this virtual machine. For example, we always use some input device such as a microphone or the speaker for the sound to connect with the virtual box. And now I will introduce how to input the camera. Please pay attention to this button device. Please select the USB. There is a list for your connect USB interface device. There is also a webcams list, but I suggest we use USB to connect the USB camera. I think most people who use this use a laptop, they have their own built-in camera, but I suggest you connect another one, especially for USB camera to the computer or your laptop, because this is easy for the VirtualBox to know the interface of USB camera. So for me, I have an interface with Logitech HD Pro Webcam C920. So I click here. You can check now. There is a mark behind this camera. So this means I have already connected the camera to the VirtualBox virtual machine. So now I will start launch the USB camera. As you can see in the point, we can use launch USB cam. This is a package name, and USB. You can use tab to auto connect the left part of the command. We can use this command. We enlarge. Sorry. So this is much better, and this will launch the camera. Okay, this is the camera. This is the image camera captured by the camera to show you this demo, and this window is just to show the image of the camera. It's not the processing or processing procedure of this cam shift. And now I will open another one. Close launch, open CV apps, which have already built in the package folder. Here, I can show you Cat King Workspace, SRC, basic function packages, and here open CV apps. We have already built in this source code package here. Okay, and cam shift. We also need to specify the topic image. Oh, I almost forgot the topic, and I will check this one. Rows topic list. We can find that the image for this USB cam is here. We can copy, right click, and then copy here. Paste. Okay. We have opened two windows for this demo. Here is a histogram for the cam shift. Cam shift demo use HSV color space for the color specify and tracking. And I will show you if we want to track this one. For example, this light blue, I will left click on this object and drag a shape. This will select the each value of this light blue object. And 吴老师，请你帮我把这个拿起来，在范围内动一动。 I want my my partner to pick up this one and move in the field of the camera， 多动一下都可以，快速一点也没问题。You can see that the camera shift tracks the object very good. And now 把它拿开这个画面。If we leave this one and then the camera shift will select the most similar one. For example, this is a little dark blue. So if we don't have this light blue, the camera shift will track the light blue. So if you want to track this light blue again, you need to put this glue near to this circle, and that will track this one again. So there is also some value we can adjust to inflect the effect of this camera shift. So we have 3 thresholds, which means V which means the light value of this object mean value, and V max is the max value of this object. So if we drag the mean value to the to be larger, we will find that maybe at some position we will not lose the track result, because this is mean which means that the light value of this object is larger than the wing mean and smaller than the wing max. Okay, and S means the certitude of this color. So it's also we can use this value to make it more specified the this value to track the object. Okay, so this is the camera shift, and I will also use this sample to show another result or another example. In this photo, for example, open APPs, as you see in the wiki, we have all this package here. I mean this launch files here. You can find all the launch file, and I will show you this one, edge detection to show the edge detection result of the object. So I will change this launch file. Edge detection launch, and then it will show you the edge detection result of the object. This is almost the perfect edge detection because it's smart and single pixel edge of each object. We can also show you the吴老师，请拿起任何一个物体来，在范围内动一下。I will let my partner to show you the yes, real-time processing result of edge detection. I can see it's very good for the edge detection. Thank you. Okay, this is the camera shift and edge detection. So Jeffrey, should we need to go on with the face detection?
Yes, please proceed.
Okay, and now I will show you the face detection and the face recognition and the people detection. Okay, I will. So for the face detection, 吴老师，请你把摄像头调整一下，面向2位的面孔。I will use this one. Rose launch open. Open CV apps face. So for the face recognition, the first procedure is to recognize the detect the face in the image. So I will show you first demo face detection launch, and also we needed to specify the topic. Okay. This they are my partner of Jupyter Robot, engineer Wu and engineer Huang. So you can see the face detection result in the demo window. So face detection, this circle, purple circle, will show you the result of the detection of face. So we have 2 faces here. we have two circles, and this blue circle means it detects the position of eyes. Maybe sometime you can see the detection of the mouth. So this is the result of face detection. But most important application for the face detection is to recognize who is who. I mean, recognize the people in the image and mark the name of it. So I will show you another demo, which is face recognition. Okay, there is a window here. So 我们只要一个人脸 ，just one in the image. So I will tell the program who is it, who is he, name Max. I type the name of Max, and the program asks me, is that right? Is that correct? Of course, yes. And please stand at the center of the camera and press enter, which means we will start to take pictures for training the program to know this he is Max. Okay. Take it first. For if we want to recognize a person very well, I mean, for different conditions, we need to take more pictures, and we'll take pictures about 5 to 10. So I need to ask engineer Wu to show different side of his face. OK， 吴老师稍微靠后一点，对，再高一点。OK， and 给我展示一下不同的侧面。OK， very well. So if you think it's enough for your training, you can type no, which means it's over for the training. Okay, and it will start another window to show you the recognition result, which you can see here, max, and this value means which the program think the reality of this recognition result. So could you please ask engineer Huang here to show the deep two face here? Okay. Oh, you look. They look very similar. So this is the right people face recognition. So this is based on the people face detection here, and this is the result of people recognition. So if you want to detect the people very well, I think you need to train more pictures to let the program know who is who. Okay, thank you. I will shut down this program. And how the program know the how the program training the result, they need to store the sample image in the computer. So I will show you where the rows store the sample image. So at this home folder, you can press Ctrl+H to show you the hidden folder, and here dot rows, and you can find open CV apps and face that the name of the person you need to detect, and this is the image we just take for training the program to know who is Max. So if you want to reset the detection result, you can just delete Max folder, and the program will not know who is Max. Okay. And the next one is people detection. So 吴老师，你们需要离远一点，然后让镜头看到你们的全身。So we also can use this rows launch. People. Oh, sorry, I forgot the package name. People detection, and also need to specify the topic. The people detection need to see a little low. Okay, to see the whole people in the image. 你俩还是离得稍微近了一点。Yes, it can detect not only one person, maybe several person. Which we have tested is more than 3 person is also okay. So I think Max is better than the engineer Huang because he have a white background and black clothes. It's much better than the Huang to show the difference between him and the background. So this is the result of people detection. Okay. Thank you very much. 然后你们调整一下那个跟随的那个场景吧，跟随。So Professor Jeffrey, can we show you the? So you need us to show you the tracking, which means follow.
Can you show after I explain?
Pardon?
You show after I explain.
Okay. I mean, we next we will show you the result of demo of follow. So we show follow on. I can't hear you. I can't hear you. Hmm?
Wait, let me explain first, then I'll pass back to you.
Okay, thank you. I see. I will stop sharing my screen. Okay, thank you. It's your turn.
Okay. Okay, it's quite heavy over here, so give me some time. I hope you can see my screen now. Hopefully it's okay. Is everything okay?
Yes, it's okay.
Okay, right. So just let me add something for the demonstration just now. So first of all, thanks a lot. Thanks David, Wu, and Huang for the demonstration. So I believe now you have some idea how to actually use the OpenCV APP library. So it is very useful for you to learn how to use that because like you don't need to actually start from scratch to write your OpenCV code or for your object recognition or something, because like it already like packaged nicely, but you need to know how to use. Okay, you need to know how to use that. Right. So I actually like before that actually I want to show you like how to use the cam shift and so on. Okay, so just now, let me review a bit like what you have just seen, and also like how you can use it for your development. So just now we show you like, for example, like this can shift example. Then you can see we actually input the image into this cam shift algorithm in order to do the processing. Okay, then if I'm not mistaken, like just now, David actually showed you like how to find the image topic by using the ROS topic list, right? So I hope by now you know what is the ROS topic list. It's actually to list down all the topic that currently active when you launch the application. So for example, when you launch whether the cam shift or the face detection and the recognition or any of this, it actually will generate certain topic that will give you some for example, like if you still remember last week, when we do the speech recognition, we will use the KWS data or the LM data in order to get the result, right? So similarly, in today's example, for the cam shift and also the face detection, face recognition, they also actually output the result in some form in certain topic, okay? So the way how you want to know all this is like, of course, the first thing is like you can read the documentation of this in the wiki, or you can open up the source code, because like these are all open source. You can actually open up the source code, which is just now David showed you where are the source code that you can read, like what kind of topic that they actually publish for certain result. But I remember, if I'm not mistaken, like if you run this cam shift, you can find something what we call the result box or something rectangular that show you the result area. And then inside there, it actually have the XY value. So by subscribe to that particular topic, you can actually get the position of the detection. So when in this cam shift example, when you detect certain thing, it will have a box that how to say, it will indicate the location of the things that it got detected. For example, like if you want to find something red or blue, just now you can see, so it actually like have a box that enclose that area, and then the middle of the box, the XY value, is something that being published out as a topic. Okay, so you can find this information by read the ROS topic list, and also to find from the source code. I mean, like this one is last time when I look at it, yeah, it is quite obvious that you can find all this result that you might be able to use. So without changing any of the original source code, you can just subscribe to this result, and you can use this result for some of your application. For example, a very simple application is like you can actually read out whether your object is on the left or on the right or on the top or below by knowing the XY coordinate of the center of the box. And also for the face detection and face recognition, I give you an example. For example, like if you make a robot, service robot, for example, a receptionist or a robot that man the counter in a hotel or so on. So when someone actually enter the view of the robot, which means it start to detect certain face, then the robot can start to greet the person. And if let's say you use other tools, for example, like you can detect this person is whether it's a male or female, then you can address the person appropriately. Then your robot will become more intelligent. So this is how you create application from all these tools that are available for you. So this is one of example that I can show you, like you can detect a face, then you can give the greeting and so on. And you can use the recognition by every time if the same person come to your robot, then your robot able to address the name. Because like you can use your voice interaction to record down the name, like just now what David have done when recording the max and so on. So you can actually do a lot of development by combining whatever that you have learned previously with the example here, so that you can create a lot more new application from here. Okay, so this is just a few examples that I would like to share. Another point that just now in the example that that David showed you, when it learned the max, the face of the max, and then when another person come in, it also detect, but actually we don't realize or we don't really look into the value, okay? Because like the name max and behind there is actually the confidence level of the program to say like how much this person look like Max. So there's a possibility that when it detect, so when it make a box of the face, it's actually just to detect the person. But for recognition, you need to look at the confidence level. If the confidence level is too low, it only indicates that the program recognize it's a face, but not sure whether it is a Max or not Max, because like the confidence level can be too low. So if just now David tried to do the same thing to learn for another person, and it might give you a better result. So that is my observation from the demo just now, that later on, if you want to use the face recognition, you might can try to learn more person in the scenario so that you can have better accuracy, and also take note of the confidence level. Okay, right. Okay, so that is my review for the demonstration just now. And so far, all the examples show you is by using the camera color information, which is the RGB information, because like for cam shift and face detection, we are using all the color information. But what happened to the distant data or distant or the depth data in our RGBD camera? So what we can do with that? So one of the example that we use a lot is for this people tracking. So I actually have one example here, but okay, later on we will show you the demo when I pass this demonstration to David to show you the demo. So you can imagine like we have this robot and it will move around, and then we have the RGBD sensor behind here that actually track object in front. Okay, then it actually measure the distance, and all this will have the point cloud for us to do the calculation. Okay, so try to imagine this scenario, and when this robot try to scan the environment in front, it actually get a lot of point cloud. Okay, so if we put this into this algorithm, so this is the point cloud that obtained by the robot. So we can see like all this point, and the color is actually red is nearer to the robot, and maybe green is further from the robot. So we can see we actually able to get the distance, and all this point by try to imagine if let's say like this is a sensor, which is the robot, and then the person is in front, and we have the person inside what we call the virtual sensing area or sensing box. Okay, so what we do is like in this follow me program, it have a very simple algorithm that it try to calculate the centroid of the object in front of the robot. Okay, the centroid means like how many points, and all these points, where is the center of that person? Okay, that person, because like when you have all the point, when you calculate the center of all these points, is actually the centroid of the object in front. So it using this centroid to track the position, whether in a lateral form or in a longitudinal form, in order to use a normal like p gain. So this is a PID, p just a p gain, which is to times a certain x and z scale. So x is in a lateral form, lateral direction. Z scale is for the longitudinal direction. So it just times with the difference. So you can know like this control system is very simple, p control. So to find the rectifying behavior of the robot in order for the robot to track the person in front. Okay, so this is basically the simple algorithm. But if you want to know more, maybe you can read this thing and also the follower code after this. Okay, so with that in mind, we can actually run this people tracking, which is we call it the follow me example. So you can find more information about this follower example over here. And in order to run this, we need to launch a few things. Okay, so this is where you need to install the Turtlebot package. But of course, you can implement this by your own, but it's easier if let's say you use the Turtlebot package, because like this is part of the demo that come with the Turtlebot package. So we launch the Turtlebot bring up, which is similar like our bring up in the sensor or the audio, that it try to launch the function. So over here we use the minimum, which is it make the Turtlebot in standby that it can actually react to our instruction. Then we launch the node, which is inside this follower. So you can see like inside there is a package called Turtlebot follower under the Turtlebot package, and got a follower launch. And we can change this follower parameter, and this parameter is all this value. So how big, or you want a big, small, very narrow, or any different parameter of this box that will actually change the behavior or the sensitivity of the tracking. Okay, so you can use this RQT reconfigure. It's something like slider to change the parameter. And also we add in one start-stop control, which is a follower control in our RC home repository example. This will be useful if when later on you want to add this follower function into your application. So you can use your Python code in a programming way to actually start and stop the following behavior. Okay, so this is the example that I would like to explain here. But now I will pass the whole thing back to David to show you this follower. And if possible, David, please also show this reconfigure to see how to actually do some adjustment on the parameters. Okay, David?
Okay, thank you, Professor. Now
Okay.
I will share my screen. Oh, can you see the screen?
I hope it's okay now.
Here is the office of Jupyter Robot, and you can see several robots here. And the robot stand in front of the camera, and he is ready for the demo. So in this screen, you can see the left bottom. There is a computer screen here, a little one, a small one, which means this is a program file interface of this robot. Now I will start to show the follow me demo. And the first is we need to launch bring up the robot. For the Jupyter robot, we have our own bring up the launch file. Jupyter robot bring up. Jupyter robot bring up launch. So the robot is ready. 那吴老师，你们听到那个声音了吗
？OK， 听得到。
And the next is Rose launch. 请站一个人到机器人跟前。Rose launch RC home. And you can see the robot is start to follow the people in front of it, and the people can go around in the office. Okay, very well. Go back and follow. It's much better for the robot to follow the people, go forward, not go for backward. 你能带它转一下吗？转到这个桌子这边来。对，哦。Maybe the robot recognize the wall in front of it much better than the people in front of it. Okay, very well. 对，继续转。You can see the result of recognition and shows you the result to the follower program to show you the result of depth points. Okay, very well. Professor Jeffrey, do we need to show the follower command?
Yes, you already show, right?
Okay. There is also a command here. I mean a node. We can use a command to control the follower movement, which means rows run. Simple. Follow. Control. Stop P1. So there is a 3 command here, and now I will use stop. The robot will stop follow. Okay. And if you want to start again, I can use F to start again. Stop. Start. Yeah, if I want to shut down this one, I can use X to stop this command, and the robot will start follow again because the command control is shut down. Okay, Jeffrey, this is the demo for the follower.
Okay, you can continue with the YOLO example.
Okay. Now I will shut down the. So for the YOLO, I will use another. I will use the virtual machine for the YOLO. Okay. And I will. Okay. Now I will go back to the VirtualBox machine, and I will input a device connect with this logic. Okay, for the YOLO, we have already set up the environment of OpenVINO in the Jupyter Robot VirtualBox virtual machine. You can see here, well, OpenVINO environment is initialized, which means the OpenVINO environment is okay for this application. And we have several application for this OpenVINO. The most important one for the first one is the YOLO. We have set up a package here. Jupyter Robot models, Open Robot Vision OpenVINO, and launch here. We have YOLO here. And before we use the Robot Vision, we need to configure the topic, which topic we will use for the vision. So we have a config file here. We can follow the photo name to config photo and change the rows .yml file. Now we have already changed the topic to the USB image. And if you use the real robot, maybe you can use camera RGB image raw or camera top RGB image raw. You can also change the topic name to your own camera. For example, for the Astra camera or the Kinect camera, you need to make sure you use the right topic name. Now I will show you the result. First, we need to bring up the USB camera. Okay, we can close here this window and new tab. Rows launch robot. Okay, OpenVINO YOLO dot launch. Sorry. We will start another window to show you the result of the OpenVINO here. Okay, you can see the program can recognize the different type of object in the image. Here is the laptop, the bottle here, chair, laptop. This is a TV monitor here. So the YOLO 3 can recognize for 80 objects for the trained model. We can see the object name here. Open models YOLO 3 name. This is a list for the recognized result of YOLO 3, and the number is 80 objects here, which means the robot the YOLO 3 can recognize. Okay, another application is open pose. I will show you the result of open pose to recognize the pose of the person, and the result the launch file rows launch robot vision open window open pose dot launch. OK， 吴老师，我需要看2个人。可以，再远一点，到那个中间去。哎 ，OK，Thank you. This the result of the open pose to show you the pose of the person recognized by the program. So you can see the different color means the different part of the people. For example, for the right hand, I mean this one, right hand is light blue, and this one is the left hand is light green, and this one is for the left leg, and this one is for the right leg. And there is also the face detection result on the face of the person. 你们离近一点，稍微一个人离近一点，我给一下那个人头的那个识别结果。You can see this is also the result of the eyes, the ears, and also the center of the face. Okay, this is the result of the open pose. The real time. This is the FPS, means the frames per second for the processing speed. Okay, and we have also a demo for the interactive face. 我需要一个人脸的画面。Open window, interactive face. Huh? Something wrong. Uh-oh. Or maybe we needed to adjust some setting for this demo. Okay, that's all. Jeffrey, that's all. Jeffrey.
Okay, thank you. So just give me some time because like my laptop is quite heavy. Okay, so let's back to. Okay, right. So thanks a lot for the very interesting demo. And actually, so just now what you see. Okay, so I hope I'm back. Okay, so just now a few things that I want to review. So first is like for the follower. So the follower is a very how to say useful application that you can include in a lot of or many of your service robot development. For example, like in our repository, we actually show what we call the party bot example, that you have a robot that can follow someone, okay, and then you can take photos, you can do some interaction, for example, like speech interaction, answer some question, do self-introduction, and also tell jokes, do some performance, like do some dancing, play some song, and so on. So with whatever that you have learned, like in the second week and also this today, plus the follower, you can actually make your robot very interactive. Okay, so this follower also, like we prepare the follower control, which is the on and off button. is actually to let you able to, like, for example, ask the robot to follow you, or ask the robot not to follow you, so that the robot can stop over there. So a lot of interaction you can do once you combine whatever that you have learned in last week for the speech interaction with whatever that you learned today and also after this. Okay, so I hope like you can be more creative to see how you can input all these things together to come up with interesting application, of course. But of course, if you don't have the robot or don't have something that can move, you can also use the simulation. But maybe we will introduce later on to tell you more about how you can use the simulation model that available in the virtual machine as well. Okay, so this is for the people tracking. And one more note that I would like to explain, like, because just now we show you the actual demo, you don't really see the data for the point cloud. Okay, we actually have a way to show you the point cloud and so on, but it's a bit too complicated to show like remotely currently, and I mean the robot and also remotely on your desktop. So you can actually try to see the how to say, the point cloud data if let's say you have like RGBD sensor with you. Okay, because like just now I also show you in the first demonstration, I show you like I use the hand to actually block the sensor, and you can see like we have the color, the black color, but we can actually show that in 3 dimension, okay, which is the RVs. Okay, but maybe we will show you the next time when we have the setting to show you how it looks like in 3D. Okay, right. But anyway, so let me proceed with the content today. So today we show you a lot of interesting application that use the image processing with the environment that you have. Okay, even with just a simple camera, you can do a lot. And even just now, before we stop for the follower, I also like let David to show you some deep learning based object detection, for example, the YOLO tree, and also the OpenVINO on OpenVINO, which is OpenPose, that you can do a lot of very accurate recognition with the image, with the vision. Okay, so for example, like the YOLO tree. Okay, so this is the YOLO example. You can real time recognize different object. Okay, and also you can use the OpenPose to detect the motion of the person, right? Like waving and what that person is currently doing. So with that, you can have a lot of information for the robot to understand what happened to the surrounding, whether what happened to the surrounding in terms of like the user that the robot interact with or the object that the user interact with. So a lot of things that you can do. So like over here, image processing application by OpenCV, then human pose, gesture recognition, deep learning based object detection. So you already see like many examples, and also these are all the framework already built in your virtual machine that you can explore. Because like we only have like 2 hours today, it's not possible to tell everything in detail, but at least I hope now you know like you have some exposed to all this information, so that later on you can look more detailed. But of course, if you want more information about certain part of the demonstration today, feel free to contact us and I will provide you more information. But everything that I show you today is already like open source. You can find the original source code in the virtual machine. So everything you can actually like look through inside the virtual machine. Okay. And of course, like vision-based manipulation. So this one is something that you add the vision with the arm that we will discuss when we have the class for the manipulation. Okay, so with that, basically we have covered the content for today, and I would like to discuss a bit before we end about the assignment. Okay, so the assignment is to, how to say, to summarize the things that you have learned and to see what you can do with the things that you have learned. Okay, right. So for today, the second assignment, okay, the second assignment is this one, image processing assignment. Okay, for this, I hope by now, just now I already give you like a lot of examples. You can combine the speech interaction, which is last week, with the Speech interaction means you have the speech synthesis and also speech recognition. So your robot able to say something and understand what the user say to him. Okay. Then you combine with the visual perception that today we have. For example, the cam shift example you can use, or the face detection that you can use. Okay, I will give you an example after I read out this. To develop an interactive robot vision application. Okay, so you need to design, develop the robot vision application using human object detection, tracking with speech interface. So I give you an example, very easy. So for example, you want to develop a receptionist robot, okay, for example. So all you need is just your laptop with the virtual machine and also just a camera. Okay, you don't need anything else, you just need this. And this setting can be done easily with just your laptop. So once you have this thing set up, so you just need to study how, for example, the face detection example. Okay, so the face detection example will give you information about like if someone actually within the sensing of the camera. So which means like anyone that move into the range of the sensor, then you can detect someone is actually appeared. So for a reception robot, so when someone come near to the counter, what the reception robot should do? Should, for example, first thing you need to give greeting. Okay, so like other than this greeting, you can do any, something extra. For example, like ask for the name, and this is where your speech interaction part come in. So you can ask like, what is your name? Then you try to remember the name, or maybe like it's within your database and so on. So you can do all this thing. Behind there is just the logic that how you want to put things together. Okay, and even you can go up to the extent that you can try to memorize the person and then memorize the name. So store in your database. We show you the face recognition today. Then the next time the same person come into the frame, the vision frame of the robot, then you can actually give the greeting, like for example, like good morning, who and who. And then you can say like, okay, what services or what kind of things that you can provide. So yeah, many things that you can do like for this. So by combining whatever that you learned previous week and today, you can actually come up with a lot of scenario, and this kind of development are all inside our scope of service robot development. Okay, so you can think of many things that you can do. So hopefully the things that we show you today, you can try to like figure out some way in order for you to design something interesting that you can do with just the minimum hardware that you have. And even you can do fancy with the YOLO example or the skeleton tracking, the open pose example, right? Okay. So hopefully, like if you can do all these things, you can upload the source code to GitHub, and then you can share with us, okay? Or we can discuss. And this is something that we look forward. Right. Okay. So I hope like I have explained everything for today. Okay. So oops. No. Okay. So hope that yeah, you can join the class group then, and we can discuss over there and so on. Okay, so I would like to close the session for today, but since we already have about 5 minutes before our end of the session, so maybe please allow me to end this session so that later on I can open up for our discussion. Okay, because I think like maybe it's more relaxing if let's say we are not like recording the interaction. Okay. So I will first close it. So please hold on and don't leave the meeting room. We will do the interaction after I stop the recording. Okay. So with Jeffrey, that, I would like to. Yes.
Jeffrey, could you please give me a few seconds? I will show the interactive face result.
Okay. All right. So since David already make it work, so maybe we can have a look. Yeah. Before we end the thing. All right, David. Yep.
Okay. Thank you. So now I will show you the result of a very interesting application, which means interactive face. So you can see that the two face recognize result here. There is a yellow point around the face, and it will show you the male or female and the estimated age for this person and his his surprise or nature or smile, and sad, maybe some I don't know how to say the 表情怎么说
Expression.
啊 expression. Okay.
Yes. Facial expression.
And there is also a red, blue, green X here. You can show you the direction, which the program can estimate the face direction to which angle or which position. So this is a very interesting interactive application. Okay, thank you.
Right, thanks, David. Thanks for the interesting show. So this one will add to like one of your tools that you can use, like just now when I say for the reception robot. So you can use this to add up like, oh, okay, so if it is a male or a female or what's the age, then you can give a more interesting address to that person that, how to say, more matched to that particular guest that appear in front of your camera. Okay, so with that, I would like to say thanks to everyone that attend. Also, thanks for David and also Max and also Huang today for the cooperation to show you very interesting demonstration. So I hope to see you again next week, same time and also same place, same link for more interesting. And next week we will talk about navigation. So it will be very interesting because like we will show you the actual navigation and also the simulation version of the navigation, and both are linked together. Okay, so I mean like Jupiter Robot have done a very nice demonstration on the navigation. So please look forward next week to show you this very interesting demonstration. Okay, so with that, say please stay on. Okay, I just stopped the recording first. Okay, thank you very much. See you next week.